Cool. Well, forgot to. Looks like I forgot to change the chroma key, but I think we're live. So, hey everyone, FusedVR coming at you, and Hassan's here with me today, and we're in the SVVR office. And apologies on the delay. It was streaming fine, and then like a minute before we said we have a bad connection. I'm like, what is going on?
Yeah.
So apologies for that, but it should be fixed. We're on Ethernet now, so I think we should have a smooth ride from here on out. And yeah, so today we're going to be building pool in VR, and right now you see absolutely nothing, but there's the pool table, and we have a cue stick that's controlled by these controllers. And I'm just going to go hop in, and if you want to explain it while I'm doing things.
So we found an awesome GitHub repo online that has a lot of these assets. We'll show you how you can use that to get started. And basically, I mean, it's pretty straightforward. Like, you're just holding on to the cue with both hands. You can click to stabilize the cue so that it only moves front and back, and then you can hit the cue ball into the other balls. So it looks like you shanked that one. And like, you can mess with the physics on this, so there's going to be a lot of tweaking that we have to do. But it's a fun project. I think that once you guys try it out, you'll see that, you know, it's easy to get something pretty interesting started, but there's a lot of opportunity for extensions too.
So I think you can pop these off the table.
Probably. Yeah.
When I was playing around with it this morning, I was like, let me see how hard I can hit this thing. I was just like, I set one off into oblivion.
Yeah. I mean, I didn't make it so that you can't pop them off the table, so I'm sure you can.
I believe. So yeah, so that's what we're going to be building. I posted on Reddit. If you guys have suggestions for an environment we want to use, we can add that in like pretty easily. The other thing, okay, this is annoying me, so I'm just gonna quickly change the chroma key because I'm like, all right, I think that should work, or not. Fine.
Yeah, so I mentioned it in the chat, and Vasant kind of touched on it too, but we're at SVVR this week, and they have a new space that they're using, which is incredible. They just have so much cool stuff here. So that was like, this is their green screen setup. It's some pretty cool stuff.
Yeah, plans for more mixed reality in the future. We're still trying to get things set up here and kind of stabilized, but cool stuff for 2017. I'm excited.
Totally.
So with that, I'm gonna just pop up in the chat here, and then you want to take it away?
Yeah, sure. Let's go. All right. So yeah, as we were saying before, this is a lot based on this GitHub repo that we found online that already has a cool pool environment. It's really awesome that someone made this publicly available, because your alternative are a bunch of assets on the Unity store that are pretty awesome, but they're all kind of expensive too. So it's cool that somebody kind of went through the work of making this out there for everybody to use. So that developer is Fabio Rem. His username is fgrem, or fgrem. So thanks, Fabio. You're helping us out a lot with this.
And yeah, if you want to follow along, there should be a link in the description on where to find this.
So we're going to download this zip file. I'm just putting it on the desktop. You can put it wherever works for you. Let's unpack this thing, and now we can pop it open in Unity. Right, let's go. FuseMan has a lot of stuff on his desktop.
I mean, it's actually, most of it's either like Steam games or past projects. I really need to clean it up though.
Yeah, Dolphin VR.
Dolphin VR is great.
I dig that.
Dolphin VR is great. Mobizen is what we used in like some earlier streams.
Mm-hmm.
Out of ammo is my jam.
Nice. Alright, cool. Well, so it looks like everything is loaded up in here. I'm just going to quickly change this layout to 2x3. I prefer that. If you're joining for the first time, haven't played around with Unity too much, just by clicking this button up here, you can change what layout you like, and I just prefer 2x3. FuseVR, I think, uses default. You can also create your own. So let's see what's in here already. In the scenes, there's this main scene, and as you can see, this has a bunch of stuff in it configured already. So this wasn't natively a VR project, so you can see that, you know, there's a lot of like there's already a canvas that is built. You know, maybe this is, I'm not sure what the target platform actually was, but we're going to convert it to work with SteamVR. So the first thing, what's up?
I think it was PC.
Oh, PC? Okay, cool. So the first thing that we're going to do is go ahead and get SteamVR. So let's pop up in the asset store. Go there. Get this plugin. And while we're waiting for that, oh, well, we can't really do anything while it's preparing the package.
Oh. Well, I'll make a
Very
quick
good.
plug though. So, I mean, SteamVR recently updated to version 3, I think, and there's a really cool interactable. I'm off screen.
Yeah, get in here.
There's a really cool interactable object system, I guess, that they introduced. So it's like, for example, in the labs longbow. So they put that in as an example in SteamVR. So let me know in the chat. I'm about to hop in right now. If you want to see more of that, my plan is to do a video on it next week. So let me know what you want to see with that.
All right.
I
Okay.
need to fix that.
Looks like we're good to go. Yeah, the thing always pops up.
Yeah.
Kind of frustrating. So now that that's done, let's wait for Unity to become usable again. Oh gosh, what did I just do to my layout? Gonna hit 2x3 again. Alright. Accept all here. And now we can get started. So first thing to do is let's put the like the SteamVR rig in here. So the camera rig is what we want. Let me zoom out from this. The first thing that you guys are going to notice, and you'll see it very soon, is that the sizing of this thing is actually pretty off. So to zoom in, that's our player space. And if you zoom out, you can see that this area is just enormous compared to our player space. So one of the first things that we need to do is actually scale down a lot of this environment. Ideally, like if you were working on a team and had like a modeler who is creating these models, they could change the size of these models to fit. These models are too big right now. But a workaround that we can do is actually put all of the environment inside or as a child of a game object and then scale down that parent game object. So that's what we're going to do here. So we'll call this game object a scalar, and we're going to put all of the environment related stuff into that. Okay, so then at that point, it's really just a process of now trying to figure out what scale works. And just from testing this before, we found that 0.05 for the scale is pretty solid to get this down to something that feels good. So now, if we zoom in, you can see that the size of the play area relative to the table, like that feels right, and you can actually try it in VR to make sure. But we do need to do some positioning to make sure that everything's where we want it to be. Right now our user is on top of the table, so let's bump this thing up a bit. That looks pretty good. And we also want to make sure that we're not right on top of this table. So let's also move it forward. So now if we jump into VR and try this out, you can see that what looks like my tracking space might be a little messed up. Either that or this got rotated.
I ran room scale earlier, so hopefully that's fine.
Let me try this again. Yeah, I think we might need to run it again. Give this a look.
What the?
Yeah, it's like tilted.
That's bizarre.
Well, actually, so I didn't get rid of everything else in here first. Oh, that's what it is. Yeah, okay. So I forgot to, there's another important step that we need to do, which is that, as I was saying before, this wasn't built for VR. So what's happening is there are a bunch of other things in the scene that we need to get rid of. It's this main camera, like we're seeing from this view, but we want to be seeing from the VR camera. So let's get rid of all of the stuff in the environment that we don't need for VR. So, I mean, you can pretty much like guess what you don't need. Like we're not going to need the cameras because we have our own VR camera. Floor's good, table's good, directional lights. You generally want to minimize, so let's see between these two which one like has the most effect. Looks like the second light doesn't actually change the scene lighting all that much, so we can get rid of that one. We need to keep the cue balls. Pool game is probably some like controller for the PC version of this game. Let's get rid of that. Score bar is a global canvas, or a screen space canvas, so we definitely don't want that. Winner message is also a screen space, and we don't need this event system. So now that we've done all of that, we can check this out. Yeah, so here you can see that this sizing feels much better. Like that is the size that a table should be. And to really reinforce the point that like it would not have worked before, if we go into this and make it 1, 1, 1, now we're gonna be I'm pretty sure like we're like in the perspective of the ball. So this is actually pretty cool. Like I feel like there's a good game that could be created out of being like on a pool ball table. You should look at this. Have you seen this?
From
like the perspective of a ball? Like there could be a really fun game where one person is playing and the other person is like
You know what would be
ball
cool?
perspective.
So there's this like hamster ball mechanic I saw on Reddit a while back. So like you have one player as a ball like scurrying around, and you have another player as like the person on the pool table, so they gotta hit these guys moving around.
That would be fun.
That'd be trippy. That would be really trippy.
Yeah, so come up with a mechanic and then we can prototype it on another stream. Okay, cool. So we've got all of the setup for the environment. Now what we want to do is actually go through the process of making it so that we can hold on to this cue in VR. So here we already have this like really well modeled cue that we can just kind of build off of to make this work for virtual reality. So the first thing that we're going to want to do is we're going to need to actually like use collisions with this cue. So let's put a mesh collider on it and let's make it convex. We can see that that collider does a pretty good job of approximating the geometry of this cue, so that's awesome. We don't need to tweak anything, and we also want to add a rigid body. But let's turn off use gravity. We don't want this thing falling. We want to control it with our hands. So now that we've done that, I mean, the next step is to figure out how we're actually going to hold this thing. And you can prototype like your own approaches to this, but what we found works well is to lock it between wherever your two hands are and to slightly bias it towards one of the hands over the other, because I mean when you're playing pool, like you usually do like a motion sort of like this and you have it biased towards like your backhand. So that's what we're going to implement here. We're going to lock it between the two hands and have it slightly closer to one of them. So we're going to build a script for that. Call it QHandler. Are there any questions so far?
There's like there's one pseudo question. It's why change the scale in the editor as opposed to on the model itself? So like when you go to FBX settings, there's like the scale setting. I answered in the chat was basically it's just a lot easier to tweak it in the editor.
Yeah, I think so too.
Off screen. But yeah, I just find it a lot easier. I mean, I think the best approach though is like tweak it in the editor, and then once you do that, go back and apply those settings to the model, just so that you can have everything in 1.1.1.
Yeah, I mean, I feel like the true solution is to apply them to the model. Like that's what you eventually want to do. And so
the true solution is you model it to scale.
Yeah.
And then never have that issue.
Yeah, that's what I mean. Like make sure that the model is correctly scaled itself. And like my approach is that until you can do that, just do whatever is easiest to get by. And like doing it in the editor just I think is easier.
I agree.
Yeah. All right, cool. So let's get into this QHandler. So first few things we're going to need are references to the front and the back hand. So those are going to be SteamVR tracked objects, which are the controllers, or tracked controllers. I'm going to call these front and back, front controller and back controller. You could come up with something that you like better. Okay, and once we have that, we actually want to go through the process of getting the queue to lock to those. So let's also create some global variables for the position that the controllers are at. We're going to need these to determine where we're actually going to place the queue. So we can set the front position, and we're doing this in update because we need to make sure that, you know, at every frame the queue is following where our hands are. Front controller dot and so now once this works, back position. You can actually do the step of moving the queue. So most of the time when you're moving objects in Unity, you can just move the transform and that's fine. But there's also the opportunity to move an object based on its rigid body. And you want to do that especially for objects that are based on or have physics interactions, because just with the way that the Unity like flow of events works, it's possible that you move the transform and the rigid body is like not updated yet, and so the transform moves somewhere, but then like the physics interaction for that frame is not valid. If we move it by the rigid body, then the physics are valid as we're making the move. So transform is what you can use to move things when like the physics interactions don't matter so much, but if they are, we want to make sure we're moving the rigid body. And that's why we also need a reference to the rigid body in this script. We'll call this QRB, and we can get that in start. Alright, so now once we have that, here's the part that we've been talking about. We can do QRB.movePosition, and we tell it where to move to. So just to show you like an example that this is working before we dive into like some of the math, we're going to just move it to wherever the front position is. So to go back, pop into Unity, you can see that eventually this will update with our outlets, and we need to give it a front and back controller. Now I want my back to be the right controller, ideally. Huh, this is not fitting into there. Let's see. Did I give this the wrong type? Oh, I think this might need to be a tracked, is it object? Yeah, I think that's what it is. The SteamVR types kind of throw me off sometimes. Yeah, so it needs to be of type SteamVR tracked object. There's just so many different SteamVR types. Sometimes I get them mixed up. Alright, so let's see. Oh gosh, I forgot to change the scale on this.
Oh, the full stick?
Yeah. So once I detect this controller, yeah, I mean, it's huge, but you can see that it's locked to my controller, and it's moving as I move my hand. So first things first, we're going to change this scaling so that we're not in the table anymore. So for scalar, let's go back, change that to 0.05. And now when I pop in, yeah, you can see that it's locked to this controller as I move it. Now one thing is that it's like rotating, and I believe that's because the cue needs to be set as kinematic. So if we open up the rigid body, we can click on this is kinematic option, and now it doesn't do those rotations as I'm moving it around. So for those of you who haven't used it before, it is kinematic. Just means that like basically all of the collisions are going to be simulated like via script rather than happening, I guess, naturally. I think that's probably the best way to explain it. You need to script the movements. What's up?
So there's a quick question from Mike on, I think in the script you used, you want to pull up the chat real bit fast there. Oh, dear. Of course I don't have the chat for you to see. Let me fix that. Turn that off. And open it.
Trying to figure out what the question will be.
So he says, I think you use tracked controller for button interactions, but object for position.
Oh, okay. So, yeah, I mean, controller wasn't working before. Usually I've used this for, I mean, we're using it for position now.
Yeah.
And then we can get the device from this, I think.
Yeah, so what I've noticed
buttons.
personally is that the device doesn't keep track of the position for whatever reason when you get it.
Yeah.
But that when you call like front controller, back controller, it does. So, yeah, that's kind of what I use. Ideally, I think you would just abstract it all with like something like VRTK. But when you're just kind of like quickly prototyping, like this is probably some of the stuff you'd do is just make sure it works.
Yeah, this makes me think about how, I mean, they announced like their new lineup of like I forgot what they call them. Maybe they do just call them tracked objects.
Yeah,
those like little attachment
weird thingies
yeah.
that you're supposed to put on an Oculus to track it.
Yeah, so like that makes sense because then like there you're just monitoring like the position of that thing, that tracked object. Yeah.
So then yeah, I guess it would make sense based on that naming.
Yeah, totally. All right, so we see that we can get the cue to follow a position of the controller. Now we just need to situate the cue at the right point between our two hands. So this part's a little bit mathy, but basically, like, we just want to interpolate between the front position and the back position and lean a little bit more towards the back position. So we're going to move it to the back position times 0.75, so essentially weigh it towards the back position a bit, but also add a weighting to the front position. So now, if I go into, oh whoops, open Firefox. Oh gosh, I just closed everything. Let me reopen this queue handler. Yeah, so we're setting the position between the back and the front and weighing it a little bit more towards the back position. The problem that FuseMan and I regularly have is that we have very different head sizes. I have a much larger head. It gets in the way how big my head is. I also have glasses, which makes it a pain. I should have worn my contacts today.
Did you see there's a Kickstarter for this like Vive attachment that like flips up the headset up and down. So kind of like, and just like, you just go like this as opposed to like it's sticking to the
Oh,
front of
that's
your
pretty
head.
cool. How do they put that on your face though? Like you have a motor on
It's
your
kinda like,
face?
I think it's kind of like the PlayStation VR.
Oh,
So like
okay.
it's got that like janky like pull out attachment.
I'm just not keen on the idea of putting anything that's motorized on my head. So it's
Oh
not
no, yeah,
motorized.
it's not motorized.
It's just like a
It's just
flip
like you
thingy.
flip it, yeah.
Okay, I see. That works. That makes sense.
You already have something motorized on your head.
It's not the same.
Yes, it is.
Anyways, getting back to work. So you can see in VR right now that here's my back controller, my right hand. Here's my left, and I'm biasing it towards the right hand, but the cue is not facing the right way. So we need to tell it to look at wherever my front hand is, and we can also do that using the rigid body. So the next line that we could add in here is QRB dot, I think it's move rotation, and we give it a quaternion, and there's a look rotation. Yeah, so we need to tell it like where forward is, essentially like what direction to look at. This is going to get into like a little bit of like, or it could get into, if you guys want to, vector 3 and like vector math, 3D math. But basically, to get this forward direction, we want it to look towards the front position, and we can easily do that by doing front position minus back position. If anyone has questions on like how you figure that out, just post it in the chat. Well, just like how to figure out, because like I feel like it comes up a lot in Unity, you know, like how do you figure out like what the direction towards a point is? And I realized the other day that like it's not necessarily like common knowledge, you know, like it's a common problem, but like 3D math can be kind of weird, and it like comes up often. So if anyone wants us to talk about that, we definitely can. Actually, screw it. I'll just go into it.
Yeah, Mike was saying like quaternions have like eaten up like 10 hours of his life, but
Yeah.
they're definitely worth it.
Yeah, so I mean, I'm not qualified to talk about quaternions. I don't really know too much about how those work. But basically, like here, what's going to happen is we're going to give it a vector 3 that represents like a look rotation, and then it's going to turn that into a quaternion for us. But the part that we can like pretty easily talk about that's also important is how do we decide where the forward direction is? And I did front position minus back position. So the intuition that I use for thinking about this is like you can look at any subtraction as a difference. So what's the difference between front position and back position? So if this was front position and this was back position, the difference would be something that points towards front position. I think that this is actually easier to think about in terms of, say, like the number line. If I had the number 5 and the number 3, the difference between those is 2. The difference between 5 and 3 is 2. But the difference between 3 and 5 is -2. So the way that I view it is like whatever you put first, like that's what you're gonna have. Like the resulting vector will be pointing towards that. So if it's 5 minus 3, 2 is pointing from 3 to 5. If it's 3 minus 5, -2 is like telling you that you have to apply a -2 to get down to 3 from 5. I don't know if any of that made sense, but that's my 1D interpretation of 3D math. So yeah, if that was confusing, just post questions in the chat and we can go more into it. But for now, I want to see how that works. So we're getting some tilt, but it's not looking exactly where we want. And the reason for that, I believe, is that from looking at this, let's see, where's this cue? It's actually not oriented the way that we would ideally want it. Like the forward direction is usually the blue axis. And so here it's looking towards something based on that forward axis, and that's not really looking in the right direction. So let me get this. Looks like having trouble seeing this in the scene view. This is odd. So there's a bug somewhere in here. I think that part of it has to do with the cue not being oriented the way that we want. Let me check this out again. Here. So it actually looks like pretty responsive in terms of, like, it is changing the look, but the axis isn't right. So we just need to figure out what axis we want to rotate it along.
So someone in the chat, and I think I did this in the starter project, was you can add an empty game object to fix the orientation of it.
Yeah, we could do that or apply a rotation via the script.
Yeah.
Trying to figure out which one to do.
I
feel
like the empty game object approach.
Okay, let's try that out then. So let's see. Again, the goal here is to get the cue to point towards this blue direction. Oh, that's why it was so confusing. So I was looking at it from the global perspective. So yeah, here it makes the problem really obvious. When I go into local view mode, you can see that the forward direction, which is again the blue of this cue, is like completely off. So let's change that. We'll call it Q rotation. Put this into there. Then we want to orient this Where's this transform? Oh. I feel like I would rather actually do this just via code. So let me, unless someone really wants to see it done with a like parent game object, I think that now like the transformation will be very obvious. Yeah, so now if we're looking at this from the local perspective, we can see that it's really okay, fine. But I'm telling you, this would be like with less than one line of code, by adding half of a line of code, we could just rotate this around the x-axis, which is that red axis, by 90 degrees, and that would make it look towards the front controller. But you guys don't want to do it that way.
Oh, wait. No, he meant he wants to see it in code.
Oh, you want to see it in code. Awesome. Okay. Because I feel like that's the
Sorry, I misread it.
the like better solution. So basically, like I was saying before, inspecting this in the editor, we saw that it just needs to be rotated by 90 degrees on the x-axis, which was that red axis. So we can apply that by multiplying in a quaternion, and I think we do Euler, and we give it a vector 3 representing how we want the like the rotation. To be done. So I thought that I could just give this, I think you can either pass it a vector 3 or separate arguments. Yeah, so I can give it a rotation in the x, y, and z direction. So to get it in the x direction, we just give it that 90. And then this should be it. So again, this is getting it generally to look from the front to the back, or from the back to the front. And then this is applying that 90-degree rotation along the x-axis. So there it is. You can see it working in all of its glory. So much math. Actually, not that much math, but math is fun. So we can actually just go ahead and hit this thing already. You can actually even make it pop up if you hit it from under it. So that's the beginning. There's more that we can add to this. So if I restart this, we can already see that there's like one clear thing that we're going to want to add. And you'll see that by watching me take this shot. So here I am, lined up, and I just completely whiffed it. Like in VR, like it's actually pretty hard without like the haptic feedback and the weight of this thing to really like hit the ball. So like try as I might, like it's actually gonna be really hard to make solid contact. So the next thing that we're gonna work on adding in is something that will let us lock the position of the cue, so that once we get in the right position, we can just work on moving it front and back. But before I jump into that, I actually want to make sure that everyone's doing good so far. Like, have any questions popped up? Let's see.
No, right now we're mostly talking about Daydream.
Okay. What do people think about Daydream?
I mean, I think it looks cool, but we're seeing like there are a lot of overheating problems. So like one person's saying like after like 15, 20 minutes, like it just like overheats and like frames start to drop, which is like really
That's
bad.
rough.
Have you tried it?
No, I haven't gotten to try it yet. I mean, I want to see how it compares to the gear, though.
I feel like the controller just makes a world of a difference.
Yeah, I mean, but how good is it? Only...
It's better than tapping on your head.
Okay, yeah. Definitely better than tapping. I mean, on that angle, I'm wondering, like, how good is it compared to, say, like, a Wiimote
It's
And
exactly a
obviously,
Wiimote.
oh, it's exactly? Okay.
Well, it's actually better than a Wiimote because they know the head position. So what they do is what they call the elbow model. So they add a little positional movement, which I think is really cool.
Dude, we need to get one. We need to get one, and we need to do a stream.
Yeah, that's what we're saying. I was like, we need to figure out how to get one. I can't see myself buying a Pixel. I don't really like the Pixel. But if they come up with another phone, another one that doesn't overheat, I'd be down.
Yeah, totally. Let's see if there's anything else in the chat. Oh, someone has a question. Mike asked how to figure out which axis to rotate around. Did that get answered?
No, I don't think
so. So I can answer that right now. That's a really good question. So let me take out, again, this is an answer to Mike Lesavage. I don't know how to say your last name, but Mike's question about how I figured out what axis to rotate around. So this was the solution. I'm going to take this out and show you like how you can get an intuition for that. So it's hard to do it. I mean, you pretty much can't do it with the headset on. But what you can see here is that look at the scene view, and I'm moving my front controller right now. I'm moving it back and forth. Now I'm going to move my back controller. So what I'm seeing from this is that my cue is pointing along the green axis, and I want to point it towards the front controller here, and it's that red axis that I can rotate along to get it to point towards that controller. Like the blue axis is already pointing towards that controller, so I want to rotate it along that red axis. So then it's just a process of knowing what color corresponds to which axis, and the easy way to remember is it goes RGB to XYZ. So R is the x-axis, so I'm going to apply a 90-degree rotation around the x-axis.
I think also, yeah, if you look at this guy, it's all labeled.
Oh yeah, that's
So
true. In the top right, it shows it.
Yeah, in the scene view, if you look at the top right, all those are colored. But I really like that mnemonic though.
Yeah,
I've never heard that before.
It's an easy way to remember it. I taught like a high school class, so you FusedMan, you know this.
Yeah.
The kids loved it. It works really well.
There's another question here.
Sure.
So Evan asks, shouldn't the variables for the position of the controllers be local variables to put those in stack in order to use the cache?
Yeah, so they that's definitely a better long-term, or like if everything was going to stay this way, that would be better. But I'm planning on abstracting this out to a different function, and that's why I made it global. I guess, I mean, you could make them local variables and pass it into the other function if you want to be like really precise about your like best practices. So I guess, yeah, the answer would be yes, that's better. I don't think that makes that much of a difference. What do you think?
I mean, we're obviously not running into performance issues here, like by any means. Like,
Yeah.
I would say it's probably not. It's a slight performance gain.
Yeah.
I would agree. Do I think it's like that much? I think it kind of comes down to that point of like
it's like small performance gain versus convenience of like being able to just like easily use it in a different method. If you want to write the best code, yeah, they should.
Well, no, if you want to write the best code, don't use Unity. Like that's the real thing right there.
That's probably true.
It's like write your own game engine at that point. But
it's slightly more optimal to use it as local variables. I'd agree with that, and I think that like you could probably test it to show that. But now we want to actually go through this process of doing the slider. Or should we take a break, you think? What do you think? How are we doing on time?
Been around 11. So the next step was
Like actually the slider.
We also started like 10 minutes late, so we can probably take a break probably closer to like 11:05, 11:10.
Okay, I'll rig up like the buttons and stuff,
Yeah, do
and then
that.
maybe. So, yeah, what we want to do now, again, to go back to what we were talking about before, is make it so that we can click a button, lock the cue into place, and then as long as the button is down, just move it front and back. That will make it easier for us to actually make contact with the cue ball and not end up accidentally shanking it as we're pushing the controller in. So this is the point where I actually wanted to abstract out some of the functionality. I'm not a huge fan of having an update function that is incredibly long. So I'm going to create this new script called update cue position. And we're going to be doing this in there. Oh, whoops. And we also want to get, we need to, like, we're going to have 3 steps for doing this cue method. The first thing is we want to figure out when the trigger is pressed down, because at that point we figure out where to lock the cue in place. We also want to know as long as the trigger is staying down, and then the last thing is we want to know when no buttons are being pressed, because at that point we just go back to our free motion of the cue. So I'll rig that up in this update cue position function. And to do that, we're going to need access to the devices for these controllers so that we can get what buttons are being pressed. So SteamVR. Actually do it in here. I think it's dot device. Call this front, and it should be always forget what the actual tracked object controller. Let's see, so if I have front controller, so I'm running into an error here. Gosh, I can't type for anything today. Yeah, so the problem that I'm running into right now is I'm just trying to get the actual controller device, but I don't know why that's not working. Let's see. I think it was, I have it written here, SteamVR controller dot input. Then I give it the index of the tracked object. Boom. Okay, yeah, that should be it. Whew, this is why I like wrappers like VRTK. It's just like a mouthful of stuff to do. SteamVR controller.input, cast it as an int, front controller.index. It's a lot of stuff. So thanks to everybody out there who makes wrappers for these. So again, I'm getting these so that I can have access to the triggers. And the back one, we actually don't need, or we can use the back trigger rather than the front one. That's just a stylistic choice. To me, it feels better. So we'll actually get rid of this front index and just use the back controller's triggers. Alright, cool. So then when we're updating the cue position, as I said before, there's 3 cases. First, the trigger is pressed down for the first time. It's held down, and then there's also the condition that nothing is held. So I think the way that we get that is back dot get trigger and get press down, and for this the encoding was, I think it was, let's see, yeah, SteamVR controller.buttonmask.trigger, and then here we'll check as long as it's being held down. And then if it's neither pressed down for the first time or continued to be pressed, our final case is that it's just free. So again, this is first press, trigger, trigger held down. I need an if here. And then this is free mode. So to show you guys that that works, let's just do some print statements in here. So this will show me that I'll call this first press. This is held. Then last we have free. So now in the editor, I can test this out. Let me pop open the console, place this somewhere where we can see it. Need to get tracking on the controllers going. For some reason they're not syncing with the queue. Oh, it's because I'm not calling update queue position. So I created this function, forgot to call it. There it is. So now, pop open the console again. And let's hook it in. So, pop this open. So now once I click down, well, I should get something. Looks like I got an error though. Oh, no, I just don't have the... So it's doing some folding here of the messages, but we can see that right now it's printing out free. You can see the counter going up here. I'm going to click it, and you see first press goes up, and also as long as I'm holding it down, the number of messages of held are also popping up. So that's the basic rigging of the controller interaction with the buttons, and next is just making sure that we lock the queue in place so that it moves forward and back. Zip.
No.
Questions?
The
see.
forward backward queue is the last step, right?
Yeah, and then it's just going to be, after we're done with forward and back, we're going to just kind of mess around with the physics. Like, I can't stress it enough that it's kind of fun to just be in there hitting the cue balls and like seeing how to make small tweaks that change the physics a lot. So yeah, I mean, now's a good time for a break if we want to take one, or I can keep going.
Well, yeah, let's take like a 5-10 minute break.
Okay, cool.
Like, just in case anyone wants to catch up, like, I think this would be a good time to do that. Alright, so then the real question is, what do you feel like playing? What? The real question is, what haven't you played?
What haven't I played? I don't know, dude. The thing is that I always feel like playing longbow.
We need to get you.
It's
I need
so
to buy
good.
Quiver. I think that's what I need to do, and you need to try that one.
Yeah, that's relevant. That's a hit you.
That is, yeah. Let's see. Have you tried? Marf. Which I'm trying to think like what you have tried and what you haven't tried.
What? So, I mean, I feel
Oh,
like,
you can try. Have you tried Vanishing Realm?
no, but I don't. I mean, I'm not that excited.
It has a bow and arrow in it.
But it's just like it's not like bite-sized enough, you know?
Yeah, that's true.
Dude, I tried Super Hot. If you guys haven't tried Super Hot, like the full game, oh my gosh, it's so good. Game changing.
Game changing.
Yeah.
I've heard mixed reviews on it actually.
Really?
Yeah.
I mean, so
Someone said they got sick from it and was like, wait, what? How?
yeah, that's really. I mean, they
I'm gonna
just
drop
shouldn't
you in
use VR.
Hollow Ball.
Oh, I've played this one.
You have?
Yeah.
Are you good at it?
I think so.
That's the real question.
The problem here is not like obliterating your real environment, or at least for Sammy. Alright, let's see. Trigger to start.
Greetings, human. Choose.
Oh, nice. The added spectator controls? What?
Let's say the arcade.
Whatever you're feeling. Let's go with. Oh yeah, I forgot that they added this in. This is really cool. I like
Where
this.
are you? So I make sure that
Oh, I'm right there.
this placement is
Should probably put the straps on. It's gonna send
I'm not
something.
worried about that as much as your health. Like that, I'm pretty sure I had to whack you if I wanted to fall.
Wait, really?
Yeah.
No, because you're like in front of me now.
Okay, cool.
You're like, yep, you got space.
I feel like the key to this is to hit it off the wall.
It's to like hit it in the corner. Use mouse arrows. Wait, but then how do I?
Well, did you realize you can use the trigger to reel it in?
They added that in. I think that's really like it's so nice. I also felt like I could never lose when that happened.
Oh, but you can't reel it in on there.
Yeah, like you have to hit it and then you can reel it in. So like whenever it's blue, you can do that.
Yeah.
They've actually added a lot of cool things. I think for like the PSVR release, and I think that it just makes it feel so much better than when I first tried it.
Yeah, the thing is that there's so much like satisfaction that you can get. It's
It's like trolling the AI.
yeah, watch. AI's not good.
He's like,
No, what?
oh, so much for that.
The backhand is so good.
Did you what was I gonna say? Oh yeah, what setting is this?
It was I think arcade maybe.
Oh, so it's not any one of the. Oh, did you lose?
Yeah.
What?
I'm afraid of hitting you.
You've got space.
Alright, I'm gonna go for real on this. Should I do score attack?
Do very hard. I don't remember what they moved everything around.
Yeah.
But do like expert.
I don't see it. So there's campaign, arcade.
Do campaign.
Oh,
Yeah. Do expert. I've beaten it once. Alright, I'm gonna move this out of the way.
Yeah, I need to figure out the face of maybe this.
I think Chaperone should tell you. Like I whack.
Oh, what the fuck?
Dude, you do not hit it hard. That is a no-no. You're actually probably gonna hit the table with your left hand. If you use your left hand.
Gosh, it comes back so fast.
Yeah, the faster you hit it, the faster it comes back.
Oh my god.
Dude, you're gonna lose. Like, you're gonna get shut out. Oh snap. Yeah, your back is up to the table.
What? I hit that. That was BS. Guys, I found the bug.
So, someone commented, I think it was RP1 Fake. I was going through comments this morning, on the Hollow Ball demo, and they were like saying they were struggling to get the Unity version to detect the collision. I think it's just like the same issue as in here. Is once it starts going like really fast, like it misses collisions.
Oh, there, I got it.
Good job.
You can put a spin on it.
Yeah, dude. The spin's like the best part of this. Yeah.
That's the key. You just gotta nail them on the first move.
Yeah, it's always like, yeah, you get screwed if you if you let it come back. You're screwed.
Yeah, I mean it's really hard when it's moving that fast.
All right, let me get this a shot. I want to see how far I can get, and then I'm gonna deal with your settings.
I tightened it.
Oh, you did actually. All right. I want to at least be that bad.
This guy Mike knows. He says super hot VR is the best thing ever. That is.
Yeah, no, well, the person I talked to said they just got sick from it, which I'm like surprised. Dude, I'm already 2-0.
That's because you're playing on easy mode.
No, this is expert. What are you talking about, dude?
Pretty sure I saw
Chat.
you. I'm pretty sure I saw you put it on.
Oh, yeah. Wait, there's gotta be something in here that tells me it's expert. I believe.
Well, there would if it was expert, but it's easy.
Someone's jealous. 5-1. Get out of here. Get out of here. Dude, they added a ton of spin. Dude, 2-1 on round 2. Oh! Did you see that? Dude, the spin here is obnoxious. No, this is round 2. Yeah, I did continue.
No, I mean like you didn't have to use them in like.
Oh, no. Yeah, this is 1 round, straight up. And I'm at 4-2. I think it's my tennis skills that help me. Oh, no.
Oh, nice.
Get wrecked. Alright, I'm done. Get back. I've beaten it a few times on expert, but like the first time I tried it, I was like, this is crazy.
How do you beat it?
You get to 5 rounds. You have to beat 2 more rounds.
Oh,
3 more rounds. 3 more rounds.
This is pretty cool too. The attention that they paid for the
Yeah.
spectator camera.
Well, they added that also recently, and if you look to your left, you'll see the spectator camera, which I think they polished it a lot over like the course of I don't know how long.
We could maybe do a stream on that.
We have.
Oh, before.
But like we could do a better one. I feel like I'll probably end up doing a workshop with it. I think
Alright.
it's All Ball's a really cool concept. And I also tried I think it was called Punch Bomb. There was a demo on it.
Mm-hmm.
That one's just so satisfying also. There are a lot of cool stuff on the store. But it's become really hard to find them, but like when you do, it's just like these are gems.
I feel like I was talking with someone about this week. There's like a completely opposite experience with. Well, on Oculus Store, I feel like it's just like hard to find stuff.
Yeah. Or at least on the Gear. I don't know about the Rift. I haven't gone to the Rift store in forever.
Yeah, I mean, it's better than for the Gear. The Gear's tough. But even then, I feel like just Steam just has way more much more content on
It
there.
has thousands of things.
And like
Not all of, most of it's not good, but like
I want to see more stuff on the Oculus Store.
Yeah. Well, I mean, Oculus is being
Yeah,
Oculus.
I mean, it's
That's the thing.
It's hard to get on there, yeah.
All right. Time to let's see. Yeah. So just as a heads up to the stream, like me and Hassan, and I mentioned this in the chat also. We're doing a workshop today. A live workshop. Well, we're not gonna live stream it just because we're still trying to figure out some kinks in like the right way to teach it, I guess, because I think it's very different from say a live stream format. But yeah, I think eventually we want to live stream it. And I think that would be really cool. So yeah, we may end this a little earlier. We usually go to 12, but we'll see how far we get. I mean, at the end of the day, we want to finish this first.
Yeah, totally.
Alright.
And we should be fine. I think that, I mean, well, 12 would probably be a good, it's like 45 more minutes probably.
Yeah.
That should be a good amount of time.
All right, sounds good.
All right,
Go ham.
let's jump back into this. So where we left off, we had created these, basically like we had just rigged this up for our 3 different cases. When we first click down the back button, when we're holding it, and when we're in free mode. So one thing that we can do right off the bat here is in free mode, we can paste in this like moving that we did before. That was free mode. Now what we'll want to add in though is everything that we'll need for once we press down the controller. And that basically boils down to the current position of the the cue and the forward position. We're going to use the current position to like offset how much forward or back it is, and we use the forward to just like know where forward and back are at that point that the button is pressed. So I'm going to do a little bit of refactoring here, and this is actually kind of related to what was brought up earlier in the chat. How do you know when to make stuff global or like local variables? So we're going to want these to be global variables because we're going to be registering them whenever we get a press down, and then we're going to actually be using them mostly when we're holding down those like the button. You could build it differently, but this is just one way to build it, and I mean it's the style that I prefer, but you could come up with your own. So we'll call this we need a vector 3 for the position. I'll call that the lock position. And we also want a vector 3 for where the forward is. So I'll call that lock forward. And when we first press this down, we want to store a value for each of those. So lock position will just be the transforms position when we lock. Or actually, that's not true. We need to use this position. So this represents where we're placing the cue. So the best way, we can refactor this later because we don't want to duplicate code, but just for now we'll calculate whatever that position is, and then lock forward will just be transform dot forward. So now that we have those, like I said before, what we need to do is actually change the way that we move the controller forward and back, or change the cue forward and back using them. So what we're really going to want to do is adjust this like move position. So let's put something like that in there, but we're not going to be using this standard position. At a high level, we want something that looks like this. We're going to have like current cue position, or like I guess lock position, and then we're going to have like we're going to add in the forward but modulated by like an offset depending on how we have moved to the back controller. So once we're in this press down mode, we use the back controller to determine how far forward or back we move this. So we need to have a, we'll call this cur offset. And we can get that. So I mean, again, this is another place where it's a stylistic choice. Like there's a few different ways that you can encode this, but what I would prefer to do is get the distance between, like in magnitude, between the back and the front, and if that magnitude increases, pull the controller back, and if it decreases, push the controller forward. So to do that, when we first press down the trigger, we're also going to need to store whatever the offset was between the points originally. So we can do that with front position minus back position, and then getting the magnitude of this. So I'm getting an error here because I haven't defined this variable yet. Okay, so now what I can do in here is I can get the current offset as the front position, the magnitude between the front and back position. And I just need to use the difference between this current offset and the lock offset to basically decide, like, are we going to be moving forward or back. So what I want to do is actually in here, there's an easy way that we could do this, which is if we go lock offset minus the current offset, what effect would that have? So let's think. If the current offset is bigger, then this subtraction would evaluate to a negative number, and we would be moving in the negative forward direction, so it would be pulling it back. If current offset is smaller, then this multiplier would be a smaller number, or it would be a positive number, and then the lock forward would also be positive, and we would be nudging the cue forward. So this actually all should work. Let's try it out in the headset and see how it goes. Okay, so I have everything lined up here. Everything's working as before. Now I'm going to click down the trigger, and oh, I see what the error is. So right now you can see that as I move forward and back, the cue is moving up and down. I wonder if anyone can guess why this problem is happening. It's kind of related to something that we did earlier. So if you want to try to guess or like pause the stream, but long story short, so it's again like another cue orientation thing. So instead of the forward being the forward of the transform, it needs to be the green direction of the transform, which is actually up. So the way that I know that again is RGB to XYZ. So G is Y, and Y is a transforms up. So right now, the transforms forward is this blue. That's why when I was pulling it back and forth, it was moving up and down. It was moving along this blue axis, but I need it to move along this green axis, which is weirdly actually the up of this transform, because this model is not, like, it doesn't work with Unity's coordinates correctly. So if I change this to up, now it will work. Or at least it should. Let's double check. Are there any questions on that? I feel like this has been a lot of weird vector stuff.
Not right now.
Yeah. So there we go. You can see that I'm not holding any buttons down. I'm moving around in free mode. I click and it locks. And now when I pull back, I get to move the cue back. I move forward, I move the cue forward. So now I can take an easier shot here by clicking, and now I can line up and hit perfectly. So I'm gonna whack this thing. Oh gosh, I hit it. So this leads to the next step that we need to do, which is that I'm hitting this thing pretty spot on, but I need to apply a force to it and like make that collision stronger so that the ball will actually keep going through the table. So that's gonna get us into some like Unity physics that we can code up right now. But yeah, if there are any questions about the weird vector stuff, just post them in the chat. Let me see if any have popped up. Nope. Yeah, I could see that. All right, well, we're good. Then we'll jump into the that physics stuff. But before we do, I actually want to clean this code up a little bit. So let's get rid of these print statements. Like I said before, we have duplicated code right here on line 41 and 34. So I think that we can actually simplify this down a bit. We're calculating the cube position in free mode every time, and we should be able to just use that again in lock mode. So let's actually change lock position to be a different variable. Let's just call this cube position. At any point, that will be this offset that we created earlier. Now we can get rid of this line, and then here use cube position, and then we can get rid of lock position, just call that Q. I'm gonna reorganize this a bit. So this is really just some like upkeeping, making sure that our code looks good. I can also show that like someone was talking about before, we can actually, like, it wouldn't be too much of a pain to make these local variables. So let's actually go ahead and do that in here, just to show that it will work. So now that we've done that, we can actually get rid of these two globally scoped variables. And I mean, overall, like, that is cleaner, that solution. Yeah, so let me just pop into the headset and see that everything still works. But I mean, really, it should be fine. I mean, all we did there was make the code a little bit more concise and better styled. Yeah, we're good. Everything's still working functionally, but we just need to make these physics better. So we can look at the physics from two angles, actually. One thing that we could do is we can add a force to the ball to make it like move more based on the collision with this cue. And another thing that I know just from like inspecting this project is that the physics materials on this table are actually not ideal for our setup with virtual reality. The way that I figured that out is that if you look at each of these balls, they have like a collider on them, and you can actually attach materials to your colliders that specify how the physics work. And if you look at the ball physics, they have like a pretty high amount of static friction and dynamic friction. And then on top of that, on the rigid body, there's like drag and angular drag to these things. So first of all, let's change up the ball physics and see how far we can get with that. We can reduce the static friction and dynamic friction. Quick science lesson for anyone who doesn't know too much about friction. Static friction is like the friction to take an object from being stationary to starting to move. And then dynamic friction is once it's moving, the friction that applies to something in motion. So I believe that usually static friction accounts for like more of the friction of an object. Like it's harder to get an object moving than it is to keep it moving. That's like some physics law. So let's see if we change these to 0.1 and 0.1. Let's see how that works out. Because I'm still not getting a really good hit on this ball. That didn't seem all that much better. So one other thing we can change is that this table, if I remember right, also has table physics on it. So this has its own set of frictional forces. Let's change these. So let's turn down the static friction so that it's not so hard to get the ball moving. And also the dynamic friction. The reason why we need to do this is that these things are colliding with each other. Essentially the ball is moving over the table. And so you can determine how the two frictions between them are combined to create like the resulting motion. And you do that using this friction combine field. I think average is probably the way to go here, but really it depends on your application. Here I'm just trying to configure the friction so that we can get a really good first hit on this ball. Gosh, I'm still shaking a little. So that was a good shot, actually. One thing that I realized is that this cue, it's a little bit too big for me, so I'm going to scale it down a bit to 0.4. Looks like there aren't any questions so far. So yeah, I'll just keep tweaking with these physics.
Yeah, and I guess like once you get it like pretty good, I think like the next step that I think a couple people wanted to see was using VRTK for like a teleporter system.
Okay. So I just want to be able to get a solid first break on this thing. Oh gosh, so I hit them straight on, and then the balls like didn't move at all. That's terrible. Why would that happen? Let's see. Oh, I think that has to do with the drag that's on them. Because they will rotate. So let's turn these down a bit too. I'm actually going to put them to 0. Let's see what happens if I do that.
Also, what mass did you use? I know I made the mass like gigantic.
What for what?
For the mass of the cue balls.
Oh, I think that they're just at 1 right now. They should all be at 1. Yeah, it looks like they're all at 1. But the friction on them was really high, and also the drag on the Reggie button. That was decent. Did I hit it head on?
I didn't
Or
see.
did I tilt it? Let's see. Because, so what I'm trying out actually is before, when I was running through this and just like specking it out, I added a physics force based on the contact with the cue ball. But now I'm just seeing if we can get a good effect without adding any physics force.
Nope.
Yeah, okay. So we're definitely going to need to add a physics force to this thing. Alright, so that will be probably our last step looking at the time. So what I'm noticing is that I can get a really solid hit on these things, but there's just not enough force to move them. So we're going to apply a force once like the cue actually contacts the ball. So we'll use that, do that via on collision enter, collision call. And we need to do a few things here. First of all, we want to make sure that we're hitting one of the balls, and there's a few different ways that you could do that. Probably the easiest here is that I noticed that the balls have a rigid body, but the table doesn't. So when we have a collision with the cue, we can just check, does the colliding object have a rigid body? If you wanted to create something like that was stylistically better, it would be good to put like either a tag on the balls or like an interface, maybe a script that tells you that it's one of the cue balls and that it can be contacted. Things like that would be better. But for now, it'll work to just check if there's a rigid body on whatever we're hitting. So let's get that component.
Mike asks, do the controllers have rigid bodies?
I don't think so. They don't have them in the editor, but when we start, they might pop onto there. I don't think, no, they shouldn't by default, right?
I don't think so.
Yeah, I don't see them in here, and that's probably for the better. Like I'm sure you could add them, but by default, you don't want the controller simulating physics. Like you just want them moving around with your hands, and rigid bodies are best. I mean, they're intentioned for when you're trying to use the Unity physics system. So as long as they're not using it, they don't need them. And browsing through here, there are no rigid bodies on these. But yeah, I mean, you could add them if you want to be able to hit stuff with the controllers. So yeah, going back to this, let's get the rigid body from the colliding object. If there's no rigid body, we can just return. So this is just a method of saying, like, if we don't find a rigid body, don't continue. And then if we do, what we want to do is actually apply a force to this rigid body. So rb.add force, and we need to give it a vector 3 representing the force that we want to apply. So let's call it Q force, and we'll define what that is up here. Now there's two steps to doing this. The first is we want to figure out a direction to apply this force, and the second is that we want to figure out like how much to scale up that direction. So let's do the first one, getting the direction. And what we'll do from that is just check where the cue hit the ball, and like a vector pointing from the cue's contact point to the contact point on the ball. That will tell us where to apply it, so that if we hit it just on the edge, we can apply a force, and that way it's like tilted off to the side. So we'll need to get a point for the tip of the cue, and an easy way to do that is to just go to the cue, and we can create a child game object that represents its tip. So looks like maybe 53.7 is a good offset in the Y direction for this Q tip. And what we want to do via script is get a point from, or get the direction from that Q tip towards where we hit the ball. So we can do collision.contacts. Contacts gives us an array of the contact points on the thing that we're hitting. We can just get the first one, and then from any contact point you can actually get what the vector 3 point is. And we want to subtract off whatever the Q-tip position is. So this should give me an error because I haven't defined the Q-tip yet. So I just added the Q-tip in. Let's wait for this to update. It actually might not update because I have other errors in here. Yeah, so I need to comment this out first. Yeah, there's the Q-tip. Let's link that up. So to get the direction, we subtract off the Q-tip's position from the point of collision, and because it's a direction, we should normalize this vector 3. That's because we don't really care about the magnitude. We just want to know where it's pointing towards. For the magnitude, we're actually going to use the velocity of the Q. So we can type in, instead of creating this thing called Q force, we can just use force direction times QRB, get the, there should be a velocity component, yeah, and then get the magnitude of the velocity to figure out, based on this direction, how strong in that direction do we want to go. So let's see if that makes it any better. Just making sure that everything is linked up here, right? Alright, let's try this out. Yeah. Oh gosh, I keep shanking the hit. Oh, much better. Oh, but I sunk the 8-ball, which sucks. Let's see if I can get that green one. Darn it. So the contacts are actually much better now. Maybe it rolls too much. Looks like there's not enough friction to keep it from stopping. We could also change it so that when it respawns, it doesn't move.
I mean, you could also just change it on the cue ball, right?
Yeah, so let's see, where's that at? I think that just changing the angular drag will actually make it roll less. Not sure what angular drag actually corresponds
That's
to.
the rotation.
Yeah, right?
Drag on rotation.
And this thing looks like it's actually spinning when we hit it, which is what we want.
Yeah,
Really
that's a
cool.
good thing. I just wish you could actually see it. It's like spinning on the edge.
Yeah, just going. I feel like this is probably the friction then. Like maybe the table friction should be higher. I mean, it's still satisfying to hit it, but yeah, this is the part where like you just have to tweak it and figure out like what feels really good.
Yeah, on Reddit, someone posted we should put this in space, and that was like, that'd be kind of cool for like zero gravity pool.
I'm sure that we could also pop this thing on the table too. Oh, maybe not.
Oh, like the height of the table?
No, like, oh yeah, I made it jump a little bit right there.
Yeah. Oh, yeah. I definitely. Yeah, you can for sure.
Yeah. So let's see. Any questions in the chat?
Do you need to scale the force based on the angle of impact? You well.
Oh, I see. Yeah, that's one way to do it.
How do you add the force? Is it like based on like where you hit it, or like what direction are you doing it in?
I'm taking the I put an artificial like Q-tip on here.
Yeah.
Then I'm getting the contact position with that collider.
Okay.
And
so
then
it's like
pointing towards that. So
then yeah, no.
it's
then
like
you wouldn't.
sort of doing that already. I feel like if you were to, the thing is that it's assuming, like there's a slight, probably like a slight inaccuracy, right? Because we're just using the velocity of the Q.
Yeah.
And applying that full velocity in that direction.
Which I think is right, because then like any like any vertical direction just gets muted by the like hitting the table.
Yeah.
So it's already naturally scaled to the x.
Yeah. So is it naturally scaled?
Yeah, it should be. If as long as you're not pushing it in the forward direction or whatever.
It's not being pushed in the forward direction, but I think what they're saying is that imagine that you get like a glancing blow. Like
oh,
then I think what they're bringing up is that you, like in that case, only part of the force should be applied in this like other direction. My intuition though is that like Unity physics, like as much as I love Unity, that like the simulation is not like that fine grained that you would even notice it. I'm
No.
not sure. So like,
Well, yeah, I'm trying to. Well,
let me think. If I hit this thing, oh, this is not.
I mean, I guess that, but that's like not. Yeah, it's just not even coded in. Like partial like collision with the ball.
Yeah, but like I'm sure that you could do math to like try to calculate it. But yeah, I don't think it would be worthwhile. So if I hit it here, yeah, so like it's if I just like nudge it, it like pops off.
I mean, yeah, it's going in the right direction. Though.
Yeah, totally. So I mean, I think that that's like a good idea for an extension, like if you wanted to add it to it. But for now, what I most want to do is make sure that the ball doesn't roll infinitely. And I think that that's happening because of the frictions being too low.
Yeah, it's probably that. It's so weird because you would never have like in the real world, your dynamic friction is almost never more than your static friction.
Yeah, right?
But like,
But
just to make it feel realistic in Unity, it makes a lot of sense to do that.
Well, let's stop. This thing is going forever.
It could also be like the bouncy.
Right, I need to do like a quick.
You're also averaging it, right? So it's 0.3 with the table. I don't know what the table friction
which
is.
is point. The table is 0.3.
So it should have been a total of 0.3.
Yeah, but that should still stop it over time, right?
Yeah.
Okay, so I need to get something off of my chest, which is the quick tangent. Let's see. So just to show you that like physics is never perfectly simulated, I think what I did one time was if you do bounciness on the table of 1 and bounciness on the ball of 1.
Are you averaging it, or do you want to take the max?
Well,
I mean, it doesn't matter. In this case, it doesn't
so
matter.
in the case that I'm averaging it, it should be 1 every time, I think. But I don't think that's what's going to happen. Let's see if this has been fixed or if it's the same. Oh gosh, where did my table go? Oh, thanks, Ron. Yeah. So, let's see. Now, ideally, it should just bounce the... Wait, it didn't even bounce. Why did it not bounce?
And the table has the table physics.
Yes.
Like that. It's like those little things. It's like, yeah, I had it. It's like, wait.
What the heck? How did that happen? How did it not bounce there? I'm actually really confused now. Okay, bounciness 1.
Play again. Interesting.
Cue ball. Snooker ball.
Oh, it could be the script. Like, actually, I don't know. Maybe the script.
Okay, let's turn off the script then. Whatever that's doing.
There you go.
Okay.
So yeah, the script
it's bouncing. Oh, it looks like it's actually like decent. Last time I checked, it would start bouncing off to infinity.
Wait, really?
Yeah. Like the more, like it would bounce and get like gradually higher. But
no,
it looks
this is like an infinite loop.
Yeah, this looks super clean. So I think that maybe they worked on it since then. It could have just been a bug in the version that I was using, but basically I'd have a bouncing ball, and like every time it would bounce a little bit higher. So this is super cool. Alright, that was just a random deviation. Are there actually any like questions before we just like take this off in random directions?
I mean, I think at this point we have most of it.
Yeah.
That it's like we can take it in random directions, and I think it's good to take it in random directions.
Yeah. I mean, the biggest thing for me is just trying to configure these physics, like the physics so that it won't keep infinitely rolling. But if anyone has a suggestion in the chat,
I'm wondering, yeah, it could also just be that script, right? That's
yeah, that's a good point.
Because clearly it's changing something in the physics materials.
Yeah.
Or something elsewhere.
Oh, yeah. What is this? It's doing a... It's changing the velocity on this.
Yeah.
Okay, yeah, this is actually, I think, maybe stopping it. Or making it so that it doesn't stop. What the heck is going on in here? Fixed update if it's greater than 0. Yeah, I'm not sure what the purpose of this is. I guess we would need to see their game to know why
I mean,
it
I
was
think that's
built
just
this
like
way.
controls, right? So like, I mean, you
Yeah.
don't have to use it.
Yeah. Well, let's see if we get rid of that and hit it. What happens? Also, what's this game object doing here?
Oh, is that the one like you were trying to use for rotation, and then you were like, ah, I'm gonna do it in code.
Probably. Oh boy! I feel like that was gonna hit me in the face.
I think it did hit you in the face.
That was so wild. Dude, this is just so much fun to play with the physics. I feel like physics is exciting in VR because like you want to learn how the world works, and like physics is one of the best feedback loops. Oh, that was a terrible hit.
I mean, but yeah, it's clearly we have control of the physics
Yeah.
now.
That was a good collision with the balls. So, but yeah, something's making them like maybe roll a little bit more. How are we doing on time here?
Probably got around 10 minutes.
Okay.
Do you want to add the teleportation in? Or I can
So
also do that. Either way
yeah, I
works.
feel like I haven't used VRTK too much.
Alright.
So
I
gonna jump
believe.
in and see if you can get this thing done. All man's to chat.
Go ham. You can imposter me.
Yeah.
All right, let's dive into the asset store. I don't think it should be that bad. I just have to look at the example that they have out there. But Stonefox is doing such an awesome. I haven't updated this. Oh, I updated it on my desktop at home. I was like, why does my laptop not have the latest version of VRTK? Seems strange. All right, so let's go ahead and import that in. And once we do, we'll just go ahead and actually no. I want to change the layout back to default because I like default. It's partly more because I was lazy to change it at first, and then I got used to it, even though it's probably not the most ideal thing in the world. All right, there and there, down. There we go. Cool. So we have this. Let's go ahead, go to examples. There should be teleport. Basic teleport. No, I want the Bezier. Bezier teleport. Pointer. There's so many examples in here. That's like pretty. That's like the. I think. What is this? Let's just do the basic teleport then. Let's save this. And then let me make sure this is working the way we want it to. Jump in here. Oh, what does this do? Script? Which button is it? None of those buttons. Call fallback boundaries SDK is being used. When did this get changed? And click the game object. Mode and select boundary. So in edit mode. Oh, sorry, in edit mode, not play mode. We're supposed to go to here and select a headset SDK. We did. SteamVR. Wait, is this version? Okay. I don't know what that was. But sure, I selected something. Cool. I think this is more than enough. And I'm now inside the ball. But we can do some basic teleporting, which is great. So then let's just go ahead and let me check that the teleporter is on this guy. And I just, yeah, perfect. All right, so let's take VRTK here. Oh, nice, he's abstracted. Ah, awesome. Thank you, Stone Fox. That was one of my bigger complaints, was like it was not abstracted away from the camera rig. But now that that's like its own thing, that's perfect. So let's go ahead, go back into main and paste. So we'll just have to set up this. So actual headset, no. Actual boundaries is this guy. Headset is this guy. Left and right. Model, oh, and then the models. Okay. So left and right. Oh, I should have just hit. Let's see. Does that? Okay, awesome. So that finds it, which is really cool. Let's go ahead and save that. And I don't know if I need a collider on that floor, but hopefully, sweet, we got it. All right, so now I can troll around in here and see how this feels. Nice. Dude, there's so much spin on these guys. It's kind of crazy. Friction, yeah, you can play with the friction on this for days. I think that's really cool. Nope. Stay. Ooh. Oh, and it bounces a lot also. It's, dude, this is so cool.
Yeah, it feels good.
It feels great.
I
I kind of.
You cleared it already? Yeah, I feel
That
like
was so bad.
the next thing would be a reset button.
Yeah, I mean, yeah. Obviously, if you're like making this into a full game, like you can do a whole bunch of things.
Yeah, but the thing that's surprising is like we're talking about, I mean, it just feels good to play with the physics. What are you using
Okay.
for the transport? The grips or?
Touchpad.
Oh, okay,
Which
cool.
is actually perfect.
Yeah,
Like,
that makes a lot of sense too.
but yeah, I think that pretty much is all the time we got. We have to do a bit of prep for our workshop, but yeah, you could have so much fun with this. I think that's like the cool thing about this.
Yeah, totally.
Yeah, so let us know in the comments below, like, other ideas like you would want to see with this and like how you'd want to extend it. And definitely, like, if you do end up using this and like make a full game out of this, because I think it's really fun, like, hit us up. I'd love to like show this off in the stream or something like that. I think that would be really cool.
And play it.
Yeah. But yeah, we'll stick around in the chat for a little bit. But other than that, I mean, that pretty much wraps up the stream. So if you haven't, make sure to follow us on social. Constantly putting out content there, so you can keep up to date with that. Or like if you want to see about the workshops and stuff that we're gonna put out later, like we'll put out all those updates there. It's a lot more faster than creating live streams every week. That's for sure. And do us a favor and like the video. That helps us a lot. Or subscribe. Like both of those are really helpful. And yeah, so that pretty much does it. So thanks, guys. And this has been FusedVR.
And Hassan.
And we're signing out.
Signing out.
All right. See you guys later.